My name is Mohammad Nor Sufian bin Muhammad Rafi and I am from Mechanical Engineering. I will start with background of study. Railway signaling is a system used to direct railway traffic and keep trains clear of each other at all times. Since the most important aspect of a railway signaling system is safety and decision making, interlocking system. In railway signaling, an interlocking is an arrangement of signal apparatus that prevents conflicting movement through an arrangement of tracks such as junction or crossing. To certify the safety standard set for railway signaling system, the interlocking software design must be taken into account. Using formal methods, in the railway infrastructure, interlocking system plays a responsible role. I will continue with problem statement. During train crossing, there are ample works which are required by human interference, which cause problem in railway interlocking system like delay, collision, chain pulling, and passenger security. This problem can be solved by applying PLC. The main task of interlocking is to provide a road request acceptable managing point and signal, which will not cause any collision. The main purpose of interlocking is to check a road request and provide a suitable one which will not cause any collision. Next for objective, there are three. First, to study and understand PLC of the automation railway signaling system. To design of railway signaling and interlocking with enhanced safety system using PLC. And lastly, to validate and simulate the workings of the system using online simulation tools and software.
Next is the literature review. The first one is the road relay interlocking (RRI). RRI is the switches on the panel that control the points and signals in these configurations. It is only large and busy stations typically use the road relay station interlocking system. They are intricate railroad networks that allow for extreme careful handling for all process. The station master has established the point, machine and signals that provide a correct track for the train, and the room control manage the arrival and departure trains. Next is the computer-based interlocking, or what we call CBI. CBI systems are interlocking systems that use electronics in place of traditional mechanical levers and electromechanical relays. It uses the same rules and control techniques as the road relay interlocking system. Software variables are employed in place of the relays that were once used to build the logic circuits for road relay interlocking. Digital input cards are used to collect field inputs, and digital output cards are used to provide outputs. The interlocking equations are evaluated by a processor using the virtual relays, which are stored in the processor memory either as algorithms or state charts in digitized form. Next is the Programmable Logic Controller, which is PLC. PLC is a digital operating electronic device that employs a programmable memory for the internal storage of instruction for the implementation of particular functions like logic, sequencing, timing, counting, and arithmetic to control various types of machines or process through digital or analog input or output modules. The programmable controller devices delivers solid-state dependability, reduced power usage, and simplicity in expansion. When the PLC wants to turn something on or off, it activates its output terminals. The status of the system feedback sensors, which are attached to the PLC's input terminals, are used to determine whether to activate an output. There are sev- there are several operations of PLC, which is the first one, input scan. Input scan detects the state of input devices connected to the PLC. Program scan. Program scan executes program created by the user. Output scan. Output scan operate all output devices connected to the PLC. And housekeeping, which is to communicate with other devices and run diagnostics. And for the last part on literature review is about ladder diagram. Advanced schematics known as ladder diagrams are frequently used to record logic structures for industrial controllers. Ladder diagrams are so named because they resemble ladders with two vertical rails for supply power and an equal number of rungs or horizontal lines to indicate control circuits. There are several working principles of ladder diagram, which is the first one is the rail. In a ladder diagram, there are two rails which are drawn as vertical lines going down the foremost end. Second one is the rungs. The rungs are drawn horizontally and link the rails to the statements of logic. And then the inputs. Inputs are actual control acts such as pushing or push button or activating a cap switch. Outputs. Outputs are electronic machines that are turned on or off like an electric motor or a solenoid lever. And then logic expressions. The logic expressions are used to formulate the desired control operations in combination with the inputs and output. And this slide is about a component that usually inside a ladder diagram, which is the first symbol is a normally open input contact. In its normal state, the contact is an open circuit. The second symbol is a normally closed input contact. In its normal state, the contact is a short circuit. And the last symbol is output coil, normally open and closes when it receives power.
Moving on to methodology. So this is the proposed block diagram of our automated railway signaling system. Our automated railway signaling system consists of a power supply which provides power to both sensors and PLC. The sensor will receive input which then will be transferred to the PLC. The PLC will provide output to the motor which give commands of forward and reverse motion of the train and also provide output to the signal which give commands of the gate to be open or closed. For communication between PLC and computer, RS-232 cable will be used. So this is the flowchart of the automated railway signaling system. It starts off by train 1 moving forward. Does it hit the first sensor of railway 1? If no, then train 1 will need to continue move forward until it hit the sensor. If yes, then gate 1 will be open and gate 2 will be closed simultaneously. After that, train 1 will continue moving forward until it hit the first sensor of railway 2. If it does not hit, then train 1 will need to continue moving forward until it reaches first sensor of railway 2. If it hits, then gate 2 will be open and gate 1 will be closed simultaneously. Once gate 2 is open, then train 2 will move forward until it hit the second sensor of railway 1. If it does not hit the sensor, then train 2 will need to continue moving forward, but if it hits, then gate 1 will remain closed and gate 2 will remain open. This process will continue when another train reaches the first sensor of railway 1. If the train hits the first sensor of railway 1, then the cycle will start looping all over again, but if it does not hit, then the process will end there.
As for the system layout, as you can see on the slide, we have train 1 and train 2. Train 1 is on railway 1 while train 2 is on railway 2. On each railway there is a gate for each railway, which is gate for R1 and gate R2. And on railway 1 there's two sensor, which is first sensor R1 and second sensor R1. As for railway 2, there is only one sensor there, which is first sensor R2. The PLC ladder diagram above shows the initial condition of the system. As you can see, the only gate that is open is gate on railway 1, and the initial position of gate on railway 2 is closed. So as train 1 is moving and it hits the first sensor, which is R1, gate R1 will open and the sensor will automatically close gate R2. So the journey train 1 is set to be 10 seconds as it represents the train is moving towards second sensor railway 1. After 10 seconds, train 1 will hit the first sensor on railway 2 and it will open the gate R2 and simultaneously close gate R1. So as the train 1 hit the first sensor on railway 2, train 2 will automatically move as the path for it is finally clear. So the journey train 2 indicates the travel time for train 2 to hit the second sensor railway 1, and it also been set to 10 seconds. So after 10 seconds, train 2 will hit the second sensor R1 and gate 1 will remain closed until another train hits the first sensor railway 1, and the process will repeat itself.
For conclusion, PLC-based interlocking system will make it much efficient because the whole controlling action will become automated. As is clear from the number of railway accidents occurred so far and still occurring, a more efficient, accurate and fail-safe system is needed. As concluded, that being the largest network and having a number of website equipments to be controlled at the same time, railway is highly in need of a PLC-based interlocking system. This system provides a remarkable change in railway system for protection purpose with affordable costs. Just that for us, thank you.